So now what you're looking at in your notes is kind of a hybrid between the old Bohr model that our brain would prefer and the new quantum model. So what we're looking at is just like a half of an atom. And so we've got here is the nucleus. This is the first energy level. This is the second energy level, third energy level, and the fourth energy level. They do go all the way up to 7. Okay, they will go on past that in your lifetime because we have filled off all that row on the periodic table, or I should say the period 7. And so we're only looking at the first 4 energy levels. And on a previous video, we did this 2n squared thing, which is how many electrons can be held maximum in an energy level. And so if I replace that n with the number 1 squared, you square it first, is 2, and I'm sorry, 1 squared is 1 times 2 would give us 2. So the first energy level can only hold 2 electrons. That's the most it can hold. So it can only hold 2 electrons based on the 2n squared. So that's why we're only seeing an s. Remember, s's can hold 2 electrons at orbital. They've got the boxes instead of the blanks. Okay, if we replace this with a 2, so if we did this, 2 squared is 4 times 2, we would see 8. This can hold 8 electrons. Well, S's can hold 2 and P's can hold 6. So the second energy level, we're going to see the S orbital, which is the sphere, and then those weird peanut shapes as we get that distance from the nucleus. The third energy level can hold, again, you can square it. So 3 squared is 9 times 2. So this can hold 18 electrons, most you can put in there. So that's 2 and 6 and 10. If you add those together, that gets to be 18. So we do not even see the D's until you get to the third energy level. And then the fourth energy level can hold 32. You can do the math. That's 18 plus the 14 would be 32. So that's what we're seeing here with the maximum that we can hold. So one thing that you were taught in high school is that it fills this energy level and then moves on to this one, fills that one, moves on. What we're going to see is that's not always true. So we're going to start easy. We're going to start with hydrogen. Hydrogen's number 1 on the periodic table. So here is hydrogen. It's number 1. Number 1 means it's got 1 proton. Remember, that's the atomic number. So we're going to assume for this unit, unit 1, that these are all neutral atoms for electron configuration. Neutral means however many protons it has, that's how many electrons it has. So for this unit, unit 1, we're going to assume neutral, same protons, same neutrons. So we can use this atomic number. For our next unit, we're going to be looking at some cations and anions, and we're going to see that they're not going to be neutral anymore. So hydrogen just has 1 electron. So if it only has 1 electron, and you were making an educated guess, wouldn't you think that that electron might be, and I'm just going to put it small, and I'm just going to use a half arrow, that it might be right there closest to the nucleus. So it's in that first energy level closest to the nucleus. So if I were doing an arrow diagram of that, and again I'm just going to draw a line, I might just draw a single arrow. You can do a half arrow as well. So where is that? Well, that's where this electron configuration comes in. The electron configuration, the first part is it's in the first energy level, which is here, so we put a 1. And then we put the sub-level. Sub-level would be an S, P, D, or an F. So basically, what shape is it in? And it's in a S. So we got 1, and then a lowercase s, and then how many electrons are there? That's just 1 that I drew, so we call this a 1s1. That is the electron configuration. So let me go over here and show you. So if I do 1s1, that number is going to be the energy level, which is also called the quantum number. That right there is the sublevel. And then this number is how many electrons. That's what we're going to see. And for S's, that number can never be bigger than 2. Okay, so we'll come back to dot diagram on another video, so we're just going to leave it there for that. So there's hydrogen. So if you look on your periodic table, carbon, and I'm going to go ahead and just write 1s here, so just to identify where that orbital is. 1s, there's just one arrow diagram. So here for carbon, carbon's number 6 on our periodic table, 6 protons. So if it's neutral, that means it has 6 electrons as well. So where do you think those electrons are? Well, I've already drawn one in there, so some students want me to erase it and draw it, but I've already drawn one. Wouldn't it make sense that this probably is going to fill up? So there's probably electron number 2. So then we're going to move on to electron number 3. So electron number 3, it can't go here. It's probably going to go out here and go there. Electron number 4, it's actually going to fill that up as well. So there's electron number 4. So there's 1, 2, 3, 4. So we got to put 2 more. And they're not going to go in the same blank because of Pauli's exclusion principle. They're actually going to spread out like that. So I've got 2 of them here, and I've got 4 of them total in this second energy level, but 2 of them are in S's and 2 of them are in P's. So the way we draw this, I'm going to go ahead and do the electron configuration. I'll come back and do that. So we've got the first energy level. There is an S. There are 2 electrons there. And then now in the second energy level, there is an S-shaped orbital. And there are 2 there. Notice I didn't put commas in between that. Now, do you notice that there's P's here, here, and there? So I have to tell the audience or whoever's looking at my configuration, which P am I referring to? So this 2 means second energy level. It is the P sublevel, and I have put 2 electrons there. So this is the configuration: 1s2, 2s2, 2p2. And if you'll notice, if I add up the superscripts, they add up to my atomic number. All right, so electron arrow diagram or orbital diagram. In the 1s, there are 2 electrons, and then in the 2s, there are 2 electrons, and then in the p's, I'm going to go ahead and draw all 3 blanks. There's only 2 electrons. The reason we go ahead and draw all 3 blanks, next unit we're going to talk about bonding. You'll know that I can put electrons in each of those boxes. All right, let's look at magnesium. Magnesium is number 12 on the periodic table. So number 12, I'm going to scoot that back. So I've already got 6, so I've got to put 6 more electrons. So there's 6. Number 7 would go here. And then number 8 would go here, 9, 10. So 2, 4, and then that's 10. So the other 2 are going to go here, 1 up and 1 down. So when I do this, you get 1s2, that's here, 2s2 here, 2p, and I put 6 total in there. Remember, p's can hold 6. So I've added up to 10. I've filled up that second energy level. Now I'm on to the third energy level. It's the third energy level. It's an S, and it's 2. Alrighty. Go ahead and put those. This is my 1s. That's my 2s. These are my 2p's, and this is my 3s. So then we've got these arrows. And then we go up, 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 and then down, 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 and this one's up and down. All right, are we understanding a little bit, hopefully? All right, so while I've pulled down, let me show you, I meant to, on a previous video, talk about Hund's rule. Remember how we went up, 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 and then we went down, down, down? That is called Hund's rule. Electrons will fill empty orbitals before doubling up. So we had Pauli's, which is why they go up, down, and we have Hund's, which is why they spread out. So I would like you to take a second and see if you could do argon, see if you can do the arrow diagram and electron configuration. Pause the video and then check. All right, here's argon, 1s2, 2s2, 2p6, 3s2, 3p6 for a total of 18. And then the arrow diagram just kind of mimics that. So from this point on, we won't be doing the arrow diagram, so I think you're probably going to catch on that. We'll practice some of those in class. All right, I'll see you on the next video.